So this is our third day of finding zeros using synthetic division. If you'll recall, in the last assignment we did, we were finding zeros by using synthetic division. Today we're going to do something a little different because in the last lesson we would always start with some number equals 0. So we would know when we did synthetic division, the first number that we should try right here should make a 0. In today's lesson, we're just going to start with the polynomial function, but we're not going to have any zeros to start with. We have to decide how we want to start finding the zeros. And the way that you find zeros, or possible zeros, so this is what we're going to do here. We're going to make a list of possible zeros. And I know that if you take college algebra at OTC after this class, I know for sure you have to do this for their class. So we're going to use what's called the fundamental theorem of algebra to find this. First of all, just looking at this equation, I know that I should have 3 zeros. They can either be real zeros or imaginaries. So that means I have 3 roots, but the roots don't necessarily have to be x-intercepts if they're imaginary numbers. So we're going to start here by finding a method to find our possible zeros. To find the possible zeros, we're going to find the factors of our constant term divided by the factors of our leading coefficient. So let's find a list of possible zeros for this problem. So I'm going to divide the factors of my constant term. This is the constant term. What numbers could I multiply to give me 12? It could be 1 times negative 12 or negative 1 times positive 12. So I know that it could be a positive or a negative 1 or a positive or negative 12. Another set of numbers that would give me 12 would be a positive and a negative 2, a positive and a negative 6. It could also be a positive and a negative 3, and a positive and negative 4. So I'm going to take these numbers divided by the factors of the leading coefficient. And we're lucky on this one because our leading coefficient is the number 1. So I have the factors of 1, which are plus or minus 1. So I'm going to make a list from here. 1 divided by 1, so 1 could be a 0, or negative 1 could be a 0. Plus or minus 2 divided by plus or minus 1 means 2 could be 1, or negative 2 could be 1. 3 could be 1, or negative 3. 4 or negative 4, 6 or negative 6, or 12 or negative 12. So from this possible list of factors, I'm going to find at least one real 0. So I'm going to do, from this list, I'm going to choose one of these numbers and do guess and check. So synthetic division, I have 1, 2, negative 11, and negative 12. So I'm just going to start picking numbers and seeing if I can guess and check one of the zeros. I'm going to start with 1. I want to see if I put 1 in, I get 0 out. So I'm going to do synthetic division. What happens at the end is I get negative 20. So when I put 1 in, I get negative 20 for y. This is not 0, so that means 1 is not one of our zeros. I'm going to try the next number. Bring down the 1. And when I add negative 12 and 12, I get 0. So this means that if the input is negative 1, the output is 0. So I just found that f of negative 1 equals 0. That means the point negative 1, 0 is one of our x-intercepts. It's one of the roots. So I found one. Once I get to this point, since I started with an x cubed problem, my answer is x squared plus x minus 12 equals 0. So now I can factor to find the other zeros. X plus 4, x minus 3 equals 0. So x is negative 4 and x is positive 3. So now I found all three zeros. I knew I would have three zeros because this was an x to the third equation. In fact, this one actually happened so that every one of my zeros was actually on this list. So I have a 0 at negative 4, 0, and 1 at 3, 0. So actually all three of these would be x-intercepts because they're all real numbers.